You have already heard the headlines about the fire aboard USS Gerald R. Ford, a laundry room fire. The flagship of America's siege on Iran pulled out of combat. Every headline repeats the same line. The ship was damaged by fire, but that is not what really happened. The fire took more than 30 hours to fully control. The structural damage was described as minor. The Navy's own assessment said the ship remained fully mission capable. So no, the fire did not end Ford. The fire was only the final page of a story that had started 9 months earlier. 283 days across 3 separate theaters without a single true maintenance reset. A deployment that quietly strained everything in ways no damage report can properly measure. A laundry room fire that any Nimitz-class carrier would likely have absorbed without consequence became the fracture that revealed the entire structure was already under pressure. So the real question is not why Ford caught fire. The real question is why a contained fire inside a laundry compartment was enough to pull 1/3 of America's siege geometry out of the most important naval operation since 1944. And the answer changes the way you think about every carrier the Navy is building next. 5 weeks into Operation Epic Fury, 60 Iranian warships are resting on the seafloor. Missile factories have been reduced to rubble. Air defense networks built over 40 years and costing $15 billion were erased within 72 hours. And yet the flagship of that siege, USS Gerald R. Ford, CVN 78, is sitting in Split, Croatia, 9 months and 18 days into a deployment originally meant to last 6 months, the longest continuous carrier deployment since Vietnam, and the ship now sailing to replace her is USS George H.W. Bush, CVN 77, the last Nimitz-class carrier ever built, still running steam catapults designed in 1955, full magazine, full air wing, zero combat fatigue. If you want to understand why the most advanced carrier ever built needed the last Nimitz ever built to cover its position, subscribe to Navy Decoded. We do not celebrate hardware. We examine what happens when hardware collides with the limits physics imposes on every system, no matter how expensive it is. And to understand what Bush is sailing into, you first need to understand 2 things: what Ford was supposed to be holding, and why it broke. In a previous video, we explained why the Navy built a 3-carrier geometry instead of concentrating its power into one giant strike force. The logic was physics, not instinct. Iran's economy and military lifeline depend on 3 maritime choke points. The Strait of Hormuz, only 21 nautical miles wide at its narrowest point, carrying 20% of the world's oil every single day. Bab el-Mandeb, the entrance to the Red Sea, roughly 16 nautical miles wide between Yemen and Djibouti, channeling 12% of global maritime trade. And the western approaches to the Suez Canal, the final corridor linking Iran to European markets. The plan called for 1 carrier at each choke point. USS Abraham Lincoln, CVN 72, at Hormuz. USS Gerald R. Ford, CVN 78, covering the Mediterranean and Bab el-Mandeb. USS George H.W. Bush, CVN 77, scheduled to deploy into the Mediterranean to seal the 3rd door. 3 vertices, 3 walls, 1 equation with no escape for Iran. But here is the detail hidden inside that geometry. When Operation Epic Fury began on February 28, 2026, only 2 carriers were actually deployed. Lincoln was in the Arabian Sea, locking down Hormuz from the east, and she has held that position without interruption ever since. Ford was already 9 months into a deployment that had taken her from the Mediterranean to the Caribbean and then into the Red Sea. Bush was still in Norfolk, still completing final combat readiness certification, still weeks away from departure. On the whiteboard, the coffin was drawn with 3 walls. In reality, it was always 2 carriers stretched across 3 positions. Ford was doing the work of 2 ships. She covered the Mediterranean, then the Caribbean, then passed through the Suez Canal to hold Bab el-Mandeb because the 3rd carrier was not yet available. The geometry was designed to be unbreakable, but it was never actually complete. And in month 9, the carrier covering 2 positions broke before the carrier meant to relieve her could even arrive. To understand what happened to Gerald R. Ford, you cannot start with the fire. You have to start 9 months and 18 days before it. June 24, 2025, the day Ford left Norfolk for what was supposed to be a 6-month deployment. 6 months. Mediterranean theater, NATO exercises, a standard rotation, deploy, operate, return, maintain. That cycle exists for a reason, because complex warships are not designed to run forever without reset. Ford never got that reset. In October 2025, the Pentagon redirected Ford to the Caribbean for counter-narcotics missions off Venezuela. That meant different sortie patterns, different maintenance cycles. A mission profile no supercarrier had ever sustained at that scale. Ford adapted, Ford performed, And then, before maintenance teams could conduct depot-level inspections, February 28, 2026 arrived. Epic fury. Ford did not go home. Ford went east, Mediterranean to Caribbean to Red Sea. 3 theaters, 3 mission profiles, no maintenance period between any of them. And that is where the engineering problem begins. EMALS, the electromagnetic aircraft launch system, is the reason Ford can generate 270 sorties per day in surge operations. It replaced the steam catapult used by every Nimitz-class carrier with a digitally controlled linear induction motor. That means smoother launches, less structural stress on aircraft, higher repetition rates, precise energy control tailored to each aircraft's exact weight. By every measurable standard, it is a generational leap forward. But that leap comes with a cost you cannot see on the brochure. EMALS depends on a network of interdependent subsystems, power conversion electronics, energy storage modules, software feedback loops. Each one depends on the others functioning perfectly. A steam catapult fails in predictable mechanical ways that a boatswain's mate can often diagnose with a wrench. EMALS fails in cascading, interdependent ways that ripple across software, power distribution, and control systems all at once. Under a normal 6-month deployment, the maintenance window resets the clock before those failure modes can compound. Ford's clock ran for 9 months and 18 days across 3 theaters without a reset. Not EMALS. Not the advanced arresting gear. Not the ship's power distribution system. Not the crew. Nothing aboard that ship was designed to run that long without scheduled downtime. Then, on March 12, 2026, in week 3 of Epic Fury, a fire broke out in Ford's aft laundry compartment while she was operating in the Red Sea. The crew contained it. There was no catastrophic structural damage, but smoke forced hundreds of sailors out of adjacent berthing spaces. The Navy's assessment still called the ship fully mission capable, but what that assessment did not address was the accumulated strain of 9 months and 18 days across 3 incompatible mission profiles. Ford stopped at Soda Bay, then moved to Split, Croatia, and she remains there today. The fire did not end Ford's deployment. The deployment ended Ford's deployment. The failure was not in one specific technology, not in EMALS, not in the reactor, not in the power architecture. It was in the organism surrounding the technology, the crew, the habitability systems. The accumulated fatigue of 5,000 people pushed beyond the operational envelope. Every maintenance schedule exists to protect. The wall that collapsed was not broken by Iran, it was worn down from the inside, and the ship sailing in to fill that gap was built to be the last of its kind. Bush was designed as the end of a line, CVN-77, the 10th and final Nimitz-class supercarrier, commissioned in 2009, not a prototype, the most refined version of a platform whose reliability had already been proven across 50 years and 9 previous hulls. The Navy's idea was simple. Ford represents the future, Bush represents the legacy, and legacies are supposed to step aside, except Ford is in Split, and legacies do not break down in month 9. Bush spent 2024 and 2025 in Norfolk, going through scheduled maintenance, system upgrades, and certification cycles. She completed final combat readiness qualification before Ford's situation became undeniable. She had not been sent to Venezuela. She had not crossed 3 theaters. She had not carried 3 mission profiles across 9 straight months without rest. She is fresh. And fresh is not a luxury, it is a strategic asset. This is what Bush brings. Carrier Air Wing 7. A full FA-18 Super Hornet complement. EA-18 Growler electronic attack capability. And 3 Arleigh Burke-class destroyer escorts. Every vertical launch cell loaded, every magazine full. Crews that have slept in their own racks. Crews that trained on a schedule not compressed into one continuous 9-month grind. What Bush does not bring is EMALS. And she does not bring the 270 sorties per day EMALS makes possible. Bush launches aircraft using steam, 120 sustained sorties per day, technology from 1955, heavy, loud, maintenance intensive. But it has also produced 0 systemic failures that pulled a Nimitz-class carrier out of a deployed combat position. Not 0 in a particularly good year. 0 across the entire operational history of the class. 50 years of hulls running this exact system under exactly this kind of sustained demand. Bush gave up the ceiling. In return, she preserved the floor. And right now, with the ceiling sitting in a Croatian shipyard, the floor is what the geometry needs. On March 31, 2026, USS George H.W. Bush departed Norfolk for the Mediterranean. The Navy's official description was straightforward. A regularly scheduled deployment, not an emergency response. Not a rescue mission triggered by Ford's fire. Bush's deployment had been planned, certified, and loaded months before Ford's laundry compartment ever caught fire. Bush was always going to the Mediterranean. That had been her assigned vertex in the three-carrier geometry from the start. But here is the problem. By the time Bush sailed, the geometry she was meant to complete had already lost the carrier that had been holding it together. Trace the sequence. In early March, Ford repositioned from the Mediterranean through the Suez Canal into the Red Sea to hold Bab el-Mandeb, the choke point between Yemen and Djibouti that controls 12% of global maritime trade. She moved because Operation Epic Fury activated the Houthi problem at the same time it activated the Iran problem. Israel's southern flank, exposed to Houthi ballistic missiles and drones from Yemen, needed a carrier shield. Ford provided that shield from Bab el-Mandeb. Ford moved because Bush had not yet arrived to hold the Mediterranean. Ford covered two vertices because the geometry required three carriers and only two were deployed. And then, while stretching across positions that had been designed for two different ships, Ford broke. When Bush arrives in the eastern Mediterranean, she will take the position she was always assigned. Lincoln holds Hormuz. Bush holds the Mediterranean. On the map, two of the three vertices are covered, but Bab el-Mandeb will have no carrier. Now run the numbers. A carrier strike group can project effective deterrence across a radius of roughly 500 nautical miles. The distance from the eastern Mediterranean to Bab el-Mandeb is around 1,800 nautical miles. That is 3.5 times the deterrence radius. Bush cannot sit in the Mediterranean and at the same time project meaningful presence at Bab el-Mandeb. One ship, two positions, 1,800 nautical miles of physics between them. Now look at the timing. March 28, 2026. 3 days before Bush left Norfolk, the Houthis launched ballistic missiles and armed drones toward Israel, their first direct military operations in the current conflict. The same week, Ford withdrew from Bab el-Mandeb. When Ford held that strait, the Houthis showed restraint. When Ford vanished from the equation, they moved inside the silence. Presence is deterrence, absence is invitation. The coffin we described in the previous video, 3 walls, no exit, was never actually built. It required 3 carriers deployed at the same time to 3 choke points. The Navy never had all 3 in place simultaneously. Ford covered 2 positions because Bush was not ready. When Bush finally deployed, Ford was in a Croatian shipyard. The geometry has been 2 carriers since the beginning of Epic Fury, and it is still 2 carriers now. Lincoln at Hormuz, Bush in the Mediterranean, and Bab el-Mandeb, the 12% corridor, the choke point the Houthis are already probing, remains open. Now stack those 3 vectors together, and something emerges that is bigger than a simple deployment problem. The Nimitz question is this: how do you sustain carrier aviation at high tempo for as long as the deployment lasts? The Ford question is different. How do you redefine what high tempo even means? How do you raise the ceiling so high that the carrier becomes the dominant node in a kill chain no adversary can match? Both questions produce valid engineering answers. Neither answer is wrong on the drawing board. But combat removes the drawing board. The Nimitz absorbs 9 months of sustained demand with mechanical systems that have broken in predictable, repairable ways for 50 years. Ford absorbs the same demand with electronic systems whose individual components are more reliable than anything that came before, but whose behavior as a complete ecosystem under continuous combat operations had never been tested. Not once, not until Epic Fury. The fire did not prove that Ford is unreliable. It proved something more uncomfortable. The Navy's modernization thesis contains an assumption that had never been truly stress-tested. The assumption is this: you can replace mechanical simplicity with digital complexity, fewer moving parts, but many more interdependent subsystems, and the ship as a whole will still be more reliable under sustained demand. Think of it this way. A mechanical clock has 12 gears. If one gear breaks, you hear it, you isolate it, you fix it. A digital clock has no gears, but it depends on a battery, a circuit board, a crystal oscillator, and firmware. Each component is more reliable than a gear. But when the battery runs out after 9 months without replacement, the whole clock goes dark at once. No warning, no broken gear to hear. That is the difference between mechanical failure and systemic failure. Ford ran for 283 days without anyone replacing the battery, and the crack did not appear in emails or AAG. It appeared in a laundry room. The technology held. The organism around it did not. The crew, the habitability. The thousands of support systems required to keep 5,000 people functional at combat tempo for 283 days. Meanwhile, Bush spent those same 9 months in Norfolk. Maintained, certified, rested. She is not sailing because she is better. She is sailing because she is available. And availability, being present when the geometry needs you, is a form of capability no specification sheet can measure. The ship designed to make the Nimitz obsolete is in a Croatian shipyard. The ship built to be phased out is crossing the Atlantic to hold the line. Not because steam is better than emails. Because geometry does not ask which ship is more capable. Geometry asks which ship is here. Available beats optimal when optimal is unavailable. A fire in a laundry room exposed something that 11,000 strike sorties and 60 warships on the seafloor could not. The most carefully designed planning equation in the history of naval warfare contains a variable nobody wrote on the whiteboard. And if that variable changes the way you think about what actually keeps a military geometry intact, subscribe to Navy Army HAD, because the next equation is already being built. Not around firepower, not around stealth, not around sortie rate, not around cost per launch, around endurance. Bush is crossing the Atlantic toward the Mediterranean vertex. Ford is in Split. Bab el-Mandeb is uncovered. Lincoln holds Hormuz. The siege continues, but now it is a funnel, not a coffin. 2 walls instead of 3. And through the gap, the Houthis are already testing the silence. $13 billion bought the highest sortie rate ever achieved from a flight deck. Digital launch precision. A power architecture built for weapons that have not even been invented yet. None of that was wrong, but the war being fought right now is testing a different question. Not how fast can you launch, how long can you last? And the ship answering that question is the last one built from the past. Running on steam from 1955, holding a geometry that the future ship helped create but could not sustain. Ford will be repaired. The geometry will eventually close again. But the question that remains, the question the next shipbuilding budget must answer honestly, is this. When you design a warship for maximum capability, how much endurance are you trading away? In a world where American strategy requires carriers to sustain operations across shifting theaters, changing mission profiles, and timelines nobody can predict, is the ship that does more really the right answer? Or is it the ship that lasts?